Okay, are we ready to get started? First thing I want to point out is the quiz has been moved from October 31st to Monday, November 5th. We're going to spend an extra lecture on chapter 4. So that's why this has been moved. All right, so everybody has it. The quiz 3 is moved to November 5th. Also, right up here, I posted this spreadsheet called Estimated Weighted Total. If you open it up, it looks like this. I went ahead and put my guess of what the weights would be for every in-class assignment and every homework. For example, the in-class assignments on your syllabus says 20% of your grade. I guessed that we might have 10, so I divided by 10. That's how I got the 2% or 2 points out of 100 for each one of the in-class assignments. 1.7778 or whatever I'm rounding for the homework assignments, and then 9.5 for the quizzes. So, at this point, Cheyenne. There you go. At this point, we're at 34% out of 100 that could be graded towards your score. Obviously, participation is 6% of it, so we'd be at 40%. So we still have 60% to go. Now, if you go here, put in your scores for each one of these assignments. Let me show you. As you put in the scores, these cells are set up to calculate your grade. So let's say you got 100 on the first in class, you got 100 on the first homework, second in class, for some reason you got a 95, homework, I'm just putting anything in here. As you can see, it keeps going and going, and then it totals this side. This right here, which will be your weighted score, is taking this total divided by the possible total you could have, and you'll notice that this matches exactly that weighted total score you'll see on Blackboard. Matches exactly. Now, as we get closer to the end, I'll have to make sure that I change all these to be exactly how many we have. For example, if we only have 9 in-class assignments, or we have 11, that's going to be either slightly higher or slightly lower, and as the class goes on, I change those. But I'll always change them on this spreadsheet and repost it. So as you're going along, either you can manually add lines, look at what I'm putting here and put it here, and look at what formula I'm using here, put it here, just copy paste actually, and add for new assignments you want to add to this, or wait for me to post another one, and I'll have the new assignments added to it already, and you can download a new one if you don't want to change it yourself. So I'm trying to do this. It's kind of new a little bit. So you can, the advantage of this, as we get closer to the final, I get a lot of student emails saying, what do I need to get a C? What do I need to get an A? What do I need to get a B? If you set this up, all you got to do is start trying all the different scores you can get on a final, and you can see exactly what you need to get an A or A minus, as long as you can kind of predict what your participation score would be. You need that in there too. So that's how this will help. Hopefully answer that question when you get closer to the end. I always say, get yourself to a point that you don't have to worry about what you have to have. You just have to worry about making sure you don't blow it. That's a lot better feeling. All right. We're going to get into chapter 4 some more. Any marketing measures? How many? 1, 2, 3. I only see 3 marketing measures. Is that correct? That seems like too few. I'm surprised. This first one's going to be a hypothetical situation that you could possibly run across as a marketing measure. You know, maybe you've been working at this company and you're being handed your first project to kind of lead. You're leading the project. And this company says, hey, we've been doing this new salad machine. Is that what it is? Salad machine? We developed this new salad machine, instant salad machine, and we budgeted $282,000 for the marketing department, for the project leader to use to do a test market. We want to see what kind of return for investment dollars on marketing we'll receive, if this thing will be picked up or not, if people will be interested in it. So you have to come up with the marketing blitz over a 3-day period on one weekend, marketing people, but you're given all these rules. Hey, we only want this much spent. Hey, we want this many ads on Friday, this many on Saturday. We want a certain amount of evening news ads. We want a certain amount of daytime ads. And you have to take all these rules you've been told in this meeting, now that you've been handed this project, and you got to figure out the best schedule for all the advertisements with all the possibilities you could be scheduling them. Which would be best? And the company says to you, we want you to reach as many people as possible with that $282,000. That's the goal. Everybody hear that? What will you do when you're setting up a linear programming model? And let me define, because your homework problem that's due on Wednesday says, develop a linear programming model. And that means three things. Some of you can't see this, that's all right. One, identify the variables, the decision variables. And then 2 and 3, you can do in any order, but it's write your objective function and your constraints. Just developing those mathematical models and that identifying your variables, that's called creating a linear programming model. So when you have a question, it doesn't mean solve it. It just says develop an LP model, linear programming, which means, and on the homework, I think I typed it out for this first homework assignment that says this on it. I even added what are your variables, objective function, constraints. And that's the whole problem. Then the next section says solve it using Excel. That's completely different than developing a linear programming model. Developing it is writing all this out, and if that's all it's asking for, you're done. You don't have to solve it. It will be a separate question or within the question if you have to solve it. So don't assume it has to be solved. We're going to start by developing a linear programming model, and I need you to open your mind to the fact that there's now way more than 2 variables possible. And there's way more than just 2 or 3 constraints possibly. You're going to take every word of this story into consideration. Is it just expressed to me a limitation? Or did it just express to me something I might be using in the objective function? But as I'm reading this, if you're not looking forward, which would kind of help you a little, your constant question is, what decisions do I have to make if this were my project? What are the decisions that have to be made? As you're reading it, I want you to come up with that, because that is your variables. What are the decisions that have to be made, and how many different decisions are there? That's your variables. And this assignment over the weekend's been already given to the other class, similar to it, not the same one, but most of the questions are about trying to figure out the variables, not on the homework that you're going to see. At the end of class, I'm going to go over the homework in detail so that you can attack it while it's all fresh in your mind, so you have a good idea what to do. Here's an example one for media selection for marketing majors. You're told Friday, Saturday, Sunday. Here's 3 options available. All right? There is daytime advertising on each of the 3 days, Friday, Saturday, and Sunday. So there's 3 options that you have to decide if you're going to use or not. Evening news advertising each day. Friday evening news, Saturday evening news, Sunday evening news. So there's 3 options there. And then Sunday game time. That's just on one day. You have to decide if you're going to use that. So there's all the advertising options in front of you that you could use. Now, here, your job is to put together the mix with a goal that I told you earlier that I hope you're keeping in mind. Whoops. Going in. All right. Here's the amount of people that could be reached if you decide to do daytime advertising, no matter which day it is, Friday, Saturday, or Sunday. There's the approximation of the amount of people you would reach. Evening news, same thing, but more people. Sunday game time, unbelievable amount of people could be reached. Now, marketing majors, if you're into your program or you're into marketing, right now you should be saying to yourself, this is an instant salad machine. Is your target market at watching football Sunday? No. Probably not. This does not get into consideration in this hypothetical question. So don't even let that enter your mind, even though in real life, it should enter your mind. And this one, forget about whether it's your target market or not. Your goal is all about reaching the most people possible, but staying within the limitations you're about to be told. Your cost, if it's a daytime, whether it's Friday, Saturday, or Sunday, $5,000 each. Evening news, no matter which day, $7,000 each. And if you're going to do a game time, you're spending more than a third of your budget on just one ad on game time at $100,000. Your budget again is what, 282, right? Okay. Here's some other kind of, hey, in this one meeting, you were also told this information. It says, the company wants you to take out at least one ad of each type. So however ads you're putting together, one of them need to be daytime. Whichever daytime, one needs to be at least one daytime ad. Evening news ad, game time ad. The company's asking you to replace at least one of those. So right then you should start thinking, well, there's $100,000 of the budget just to fulfill that rule or limitation that we're being dictated to us. So now that only leaves us with $182,000 if we don't do another game time to spread among these other ad possibilities. That's what I need you to tell me, where they're going to be spread out to. Next, there's only 10 daytime spots available each day. You hear that? I want you to start thinking about the decisions you have to make and now turning them into variables, and the statements I'm making right now, which variables would be used related to that statement. Let's talk about the variables. Someone give me one variable. Did it fall? I don't know what happened. I heard something. Give me one variable. One decision has to be made.
How many ads during daytime on Friday?
Daytime Friday ads. How many? I don't know what to call it. Daytime Friday. DF. How's that? DF is equal to number of, if you were doing this on the homework, you're giving me the variable of what it represents. Number of ads, daytime ads. Oh, this is daytime Friday. Okay, on Friday. If that's true, then we need a variable to decide how many are on Saturday. We need a variable to decide how many of these daytime ads on Sunday then. Is that correct? Everyone agree with that? So I got daytime Saturday, daytime Sunday, also with the same definition except change the word Saturday, Sunday. Those are three of the variables right there because you have to decide how many ads for this whole weekend. So give me another variable I'm forgetting. Anytime, this is called participation. Evening news ads. On which day did you say?
Friday, Saturday, Sunday.
Three different variables? Exactly. Three more variables. So this would be evening, that's an equal sign. Evening Friday, evening Saturday, evening Sunday. Wait, I gotta distinguish this, don't I? I'm sorry, this is Saturday, this is Sunday, this is, what am I using up there? STSUN. Equals. Number of evening news Friday ads, number of evening news Saturday ads, number of evening news Sunday ad. Is that all our variables? So anybody tell me if there's any more, and if so, what are they? Game day. There's only one day that has the game day slots available, so we're going to call that, I'm just going to call it Game Day Sunday, GDS, I guess, equals the number of ads placed during game time, during game Sunday. How's that? However you want to label it, as long as it makes sense. During game Sundays. Any other variables? I think that's it. We're only presented with 7 different opportunities as to where we can place these ads. Now, right now in your mind, you're saying, okay, I have 282,000. If I start subtracting every time I place an ad, and I want to reach as many people as possible, so where do you get your bang for the buck? Is my cost per person, 75,000, spending 100,000, less expensive per person compared to spending 7,000, reaching 400, is my cost per person. Because if you couldn't write a linear program, this is the kind of thought process you'd have to go through to meet what you're being asked to do, which is maximize the number of people that will see this ad with the 282,000, but stay within these limitations we're asking to stay in. One of the limitations, again, was that there has to be at least one daytime ad. Let me say that again. There has to be at least, over the weekend, one daytime ad, less than equal, greater than equal, or equal to 1. At least one daytime ad. At least means no less than 1, 1 or more. I heard a lot of less thans. Greater than equal to 1, and then it's whatever variables represent the number of daytime ads you're going to place. Give me how many variables are involved on the left side? Say it again. I heard it. I hear it. How many variables represent daytime ads? 3 of them. Those 3 variables. DF plus D plus DST plus DSUN, whatever variables you want to call them, greater than or equal to 1. You're telling the program, the computer, hey, when you're helping me decide where to place these, I'm telling you, make sure we're reaching as many people as possible, but make sure that one of the ads we're placing is during the day. Did it also say 1 during the evening? I think it said 1 during the evening also, is that correct? And 1 during the game, I believe. So there's got to be a greater than 1 and a greater than 1. Let's do the game day one. How many variables are on the left with the sentence that says at least 1 game day ad has to be placed on Sunday? 1 variable. That's it. GDS. Now on the one, the other one says at least 1 evening news ad over the weekend. So you've got to have the variables that represent the evening news. What is that? EF plus EST plus ESUN is greater than or equal to 1. So you're taking these statements and you're turning them into equations based on the words and figure out which variables would be representing those words. We passed all that from the previous slide. Was there another one here? Let's see, at least a mixture of TV. This wasn't even on this slide. Here we go. They want you to take at least 1 ad of each type, daytime, evening, game time. Further, there are only 2 game time spots available. There are only 2 available, less than equal, greater than equal to 2. Less than. You can't go over 2. Less than equal to 2. Now, the statement said there are only game day, Sunday, 2 spots available. We put less than equal to 2 because that's all available, but what do we put on the left to represent the possibility of spending that money in that category? How many variables? How's that? 1 variable that represents game day, Sunday. So GDS has to be less than equal to 2. There are 10 daytime spots available each day, daily. So less than equal to 10, does it say and there's only available 10? 10 spots, that's the most we could go, correct? So less than equal to 10, greater than equal to 10, or equal to 10? Less than equal to 10. Now let me read it again. There are only 10 spots available for daytime each day. Now, I've had a lot of students say to me, you would add up each of the variables for daytime, it's got to be less than equal to 10, but you're missing that little part of the sentence that says each day. That means there's up to 10 on Friday, up to 10 on Saturday, up to 10 on Sunday, but you do not change that to 30. You write those each as separate constraints. Each one of them are on their own. So you have Friday daytime, less than equal to 10. Saturday daytime, less than equal to 10. Sunday daytime, less than equal to 10. That's how you present that sentence. In one sentence, that's 3 constraints, because if you were to make that 30, you'd go DF plus DS plus daytime Sunday. The computer doesn't know the difference, and it could schedule all 30 on Sunday, but there's only 10 spots available. That's why you got to separate it individually. Okay. Next it says there's only 6 evening news spots available, again, daily.
I'm sorry, but for the game day Sunday, could you technically have it as 1 constraint, or is it still the same?
Which one are you talking about? Less than equal to 2, or you have to have at least 1?
Yeah, so like
there's only 2 spots.
Yeah, so 1 is less than equal to game day Sunday, which is less than or equal to 2. So you have 1, I guess 1 less than or equal to GDS, and then I don't know. I'm trying to like put it.
Oh, you want to
like
write these 2 in one sentence?
Yeah.
Yeah.
So that's
Yeah, but you won't be able to enter it in the computer this way, but this means the same thing. I'm going to do this one on the left, so GDS is greater than or equal to 1, there it is, greater than or equal to 1, and on the left, it's less than, I'm going to put this one on the left. Now, those are written as 1 constraint, but you still got to break it up to be able to enter it in the computer to solve it, whether it's Excel or.
Okay,
so yes, I'll accept that, because that means the same thing.
Okay.
But you're about to see an example on the next example where you can't leave it in the format in which you wrote it. You have to get in the habit now to make sure that each of them have been written, and then somehow maybe algebra has to be applied to make it ready to be solved using Excel or the software. You got to get at that point. And we're about to see that in the other example. So far, we fulfilled everything. We got right here where it says 6 evening news spots. I was just about to say, how many constraints is that? 6 evening news spots daily. 3 constraints, because again, each day is separate. So you represent each variable. There's only 6, does it say 6? Only 6 spots available on Friday evening, 6 spots available on Saturday evening, and only 6 spots available on Sunday evening news. These represent evening. You know, what is that? EF, EST, E Sunday. How many constraints is that already? 1, 2, 3, 4. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're at 10 constraints. You've never seen one with 10 constraints yet. I don't think we're done. The company has asked you to have at least 5 ads per day. Not daytime ads. It's saying 5 ads per day, whatever combination you're going to use. So it's less than equal to 5 or greater than equal to 5? Because it says at least. So greater than equal to 5. Now look at the words. The left-hand side has to be whatever variables represent these words. At least 5 ads per day, such as 5 ads on Friday. How many variables represent Friday? 2. So it'd be however many daytime ads Friday, plus however many evening ads Friday, added together, have to be greater than equal to 5. Because that's how you change that sentence. It says 5 daily, so now we got to do Saturday. How many variables are greater than equal to 5 representing Saturday? How many? 2. Daytime Saturday, and plus evening Saturday. And then Sunday, at least 5 ads for Sunday. You're going to put Fridays plus Saturdays plus Sunday. 3 variables. Because Sunday has that game time possibility as well as daytime and evening. So there's 3 more variables. You ready? Keep going. Then the company said, and by the way, do not spend no more than $50,000 on Friday. No more than $50,000. Less than equal, greater than equal to 50,000. Less than equal, 50,000. Slip that in right here. 50,000. The left-hand side has to represent however it is you would be spending money on Friday, because that 50,000 is talking about Friday only. You already told me the number of variables represented by Friday are 2. Is that correct? But the variables represent how many ads we'll have on Friday. This is talking about how much you'll spend on Friday. You've got to convert those variables to money. So what would, let's see, the 2 variables, let me look at a Friday here. Where are they? Is this it? D Friday, E Friday. So it's daytime Friday, evening Friday. All I got to do now is convert those to money. DF, what will I do with it? Multiply it by the cost, which is, you said 5,000? 5,000, where am I, right here? So 5,000 times daytime Friday plus daytime or evening Friday, which are 7,000 times evening Friday, however many daytime Friday, however many evening Friday, times their costs when added together cannot be more than 50,000. It's got to be equal to or less than $50,000. Then it says Saturday, no more than 75,000. I'm going to stop writing them out. I think you're getting it. Plus, if you look at the slides, you'll see we're at like 17 constraints already. Spending 75,000 on Saturday, less than equal or greater than equal? Less than equal, how many variables represent Saturday? 2 variables. Make those 2 variables be multiplied by their individual cost, which would be 5,000 daytime Saturday, 7,000 evening news Saturday, added together, less than equal to 75,000. We covered everything we talked about so far. Before I go on to the next slide, there's something here we didn't talk about yet. You see a limitation in the beginning of the story. Can't spend more than $282,000. That's a constraint. Less than equal to $282,000 or greater than equal. less than equal 282,000. How many variables are on the left side of this statement? 7 variables. Every one of the variables, because you're going to be buying ads on most, if not all of those, times their cost. So let me go back to it. Oh wait, I got it right here. We're going to do every variable. Daytime Friday times the cost of 5,000 plus daytime Saturday cost of 5,000 plus daytime Sunday times the cost of 5,000 plus evening Friday times the cost of 7,000. Evening Saturday, evening Sunday, each time 7,000 plus day Sunday times, what was the cost on that? 100,000. Added together, all of those variables times their cost, less than or equal to 282,000. All right. Let me see. Is that it? Do we have more? There is no more to the story other than an objective function, which I told you what the objective is. So now I'm going to ask you to help me write it by telling me max or min? Max. Okay? Let me put that. Max. Barely see it. All right. Max. We could put the variables, but all that would say then is we're maxing the amount of ads we're placing, because each variable represents how many we're placing. But we're trying to max something else, which is the number of people we're reaching. So I got to take each variable and turn it into the number of people we're reaching. So your objective function is going to be how many people are reaching on daytime ads. 3,000 times daytime Friday plus 3,000 times daytime Saturday, blah, 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 blah. Evening, 4,000 times evening Friday, 4,000 times evening Saturday, 4,000 times evening Sunday, 75,000 times game time Sunday. All 7 variables multiplied by the audience they're reaching, added together. Stop. No less than equal, no greater than equal. And it looks just like this. The variables are a little different up here. How many would be reached with every one of those daytime ads? How many would be reached with each of those evening ads? And how many are reached in the game time data? That's what we're trying to maximize spending our money. Here's our variables. The first 3 variables, there has to be at least 1 ad of each type. And we wrote those 3 out because there's daytime, evening, and game time. The next 3 variables is there's only 10 available each day. Friday, Saturday, Sunday. The next 3 is there's only 6 evening ads available each evening. Friday, Saturday, Sunday. There's only 2 game time Sunday ads available. There's that representation. We want at least, the company says at least 5 daytime ads. Well, I'm sorry, 5 ads on Friday. Daytime Friday, evening Friday. At least 5 ads on Saturday, daytime Saturday, evening Saturday. And at least 5 ads on Sunday, daytime, evening, game time. Don't spend more than $50,000. There's Friday, how much we would spend if we place those. There's evening on Friday, we place those. Less than equal to $50,000. Don't spend more than $75,000 on Saturday. There's the cost for daytime Saturday, the cost for evening Saturday. Don't spend any more than $282,000. There's the cost for every one of our different decisions that have to be made, all the 7 different ad possibilities. And we never have to do this. We would never place a -1 ad. It's impossible. This whole class, right, all variables are positive. We don't have to state it out. Now, you have to be so familiar with the output. Remember on the homework I said, hey, constraint 2's right-hand side is increasing by 60. It's going from, and I give you the value, and then I give you the value, what it's going up to. You have to be at the point now where if I said constraint 2 is increasing, right-hand side is increasing by 50, you got to know which one to look at. I'm not going to give you that hint anymore. What is it now and what's it turning into? You have to know where to find the right-hand side of constraint 2 when you look at an output. And you've got to know how to answer any question about the output, and no matter which output I'm showing you, the exact same information is being given to you, just in different formats. So every question I'm asking you is somewhere out there. For example, how many game time ads are you going to spend $100,000 a piece on? That could be one of the questions. And your answer is going to be what by looking at this output?
2.
I heard it 2. And what he did is he looked at the variable that represents game time ads. At the top of the output, this is just the top portion. These are your optimal values. And it says you should be placing 2 because that's the most you can place. And if you divide 100,000 by 75,000, you'll see that's probably the least expensive reach as far as whether it's your target audience. That's a whole different story, but this probably has nothing to do with target audience. It's all about, here's your assignment, here's the rules, maximize people you're reaching with this budget. Another question might be, Friday night during the news, are we running any ads? No. Are we running at least 5 ads on Friday altogether? We are. Even though I just got done asking about Friday night ads, you said none. Friday night has 0, but Friday day has 8. So Friday combined has at least 5. Saturday combined has at least 5. Is that true or false? True. True. Saturday during the day, 5. Saturday evening, 0. Right, that's at least 5. And we have at least 5 on Sunday. We know 2 on game time. Evening Sunday, is that evening? And evening Saturday, 3. Wait a minute. Where's Sunday? Daytime Sunday, 2. Evening Sunday, 1. There's 3. Game time Sunday, 2. There's 5. I'm using the wrong variable. What is if we schedule it exactly as we had it here, or if we do something to try to find maybe an alternative optimal solution, no matter if we found an optimal solution different from this one or not, none of the solutions will reach more people with all of these restrictions. How many people is it will reach the max we can reach? That's right. The objective function value at the very top is exactly what we wrote the objective function for, which happens to be the max amount of people reached with these restrictions that we were given. 199,000 people, and that's the most you can reach, and stay within those restrictions. And so just run with the one being recommended, because there's the one of the optimal solutions right there. It may be the only one. You know, you have to play around with it to find out, but even if there is an alternative, you're not getting any better than that. 199 is the best you're going to get. All right, here we go. This is the same problem no matter which edition you have at this point. At the end of chapter 4, number 1, and I've already posted the answer to this. Don't run on Blackboard and look though. I want you to help me through this without having the answer on your PowerPoint in front of you. Are you ready? You're going to help me through this. I'm going to read it while I'm writing here. The Westchester Chamber of Commerce, it moved. Come on. The Chamber of Commerce periodically sponsors public service seminars and programs. Currently, promotional plans are underway for this year's program. Advertising alternatives include television, radio, newspaper. Audience estimates, cost, and maximum media usage. Now, just pretend that number is like an index number. And odds are, since the word maximum is being used, higher the better. And we'll see if it's even being used in any of these, but it's just like an index number. That's a calculation that calculates that. And maybe in this particular form of advertising, your goal may be to get the highest maximum media usage number you can get. Who knows? But that's how we're looking at it. To ensure a balanced use of advertising media, radio advertisements must not exceed 50% of the total number of advertisements authorized. Okay, we'll stop right there. I'm going to show you a trick to these sentences because you have a lot more just like that coming up in your future. But before I do that, I need someone to help me take a guess, if you feel like you can get it, how many variables, if you were the person, you're handed this project, you have to make a decision of a mix. Is that what it says? Is it saying? We gotta go here. What is the allocation of the budget? No. Here we go. How many commercial messages should be run on each medium to maximize total audience contact? Look at the choices. How many variables?
6.
I hear 6. I hear 3. I like 6. But because this is all over one day, I think the only choice you have is How many should I do television? How many radio? And how many newspaper? If it were 2 separate days, definitely 6. Because you would have then television one day, television the next day, and so on. Since it's all over one day, we have 3 variables. I'm going to go with T, R, and N. Don't forget, you always have to define your variables. T is going to be our number of television ads we're going to recommend. And R is going to be radio ads, and N is going to be newspaper. I don't need to write it out. Okay, here comes that sentence now. You ready? My hint, when you get these sentences like this, you got a lot of these coming up, is to write it out exactly as it reads, and then figure out how to change it to fit the software. I'm going to write it out just like the words. Radio advertisements must not exceed. Radio advertisement is represented by R. I'll start right there. Must not exceed 50% of something. Must not exceed. Less than equal, greater than equal. There you go. R, less than equal to, must not exceed 50% of, I didn't give you a hint there, the total number of advertisements authorized among all 3 of them. However many ads are going to be total, you cannot have more than 50% of them in radio. You ready? Radio ads cannot exceed 50%, 0.50 I'm putting, of times all the ads, which are going to be the number of television, plus the number of radio, plus the number of newspaper represents all the ads. That's how it reads. That's how I wrote it out. Now I got to use algebra. If you have any variables on the right side of an equality, less than equal, greater than equal, or equal, you have to then use algebra to get it to the left side, where either you have nothing left on the right, so it's a 0, or a number, but no variables. So I'm going to use math to turn these all into individual variables on their own, and I get R is less than equal to 0.50 T plus 0.5 R plus 0.5 N. And that's it on the right side. I'm going to subtract 0.5 T from both sides, 0.5 R from both sides, and I'm subtracting 0.5 N from both sides. So now I'm looking at this left side, and I'm going, wait, there's an R on both sides. I have an R on the left and a minus, I'm subtracting a positive, there's a positive 0.5 R there. So I got to subtract, whatever you do to one side, you got to do to both. So I got to subtract 0.5 R. If I have 1 R minus a half of R, I have a positive half of R still left. The T and the N have nothing on the left. So when I subtract them from nothing, that turns into negative 0.5 T minus, because a negative 0.5 N. This is my left-hand side. Less than, equal to, what's the right-hand side? 0. There's nothing left. But now it's a number, and it's ready to enter into the software. And when I'm entering this one, underneath the R, I'm going to put a 0.5. Underneath the T, I'm putting a negative 0.5. Underneath the N, I'm putting a negative 0.5. I'm going to put a less than, and I'm going to put a 0 on the right. And that's how you would enter that in to be solved, that constraint. All right? Next sentence says, in addition, television ads should account for at least 10% of the total number of ads. Just write it just like it read. Television, which is T, should account for at least 10%. Greater than equal, less than equal, or equal? Greater than equal 10%, 0.10 of times all the ads. T plus R plus N represents the total of all the ads. The total number of ads would be, because those are the only 3 options we can put them in. You solve this one the exact same way I just did the other one. The only difference is you have a greater than equal, I'm going to multiply the 10% times each variable. T is greater than or equal 0.1 T plus 0.1 R plus 0.1 N. And now I'm subtracting 0.1 of each variable for both sides. Minus 0.1 T, minus 0.1 R, minus 0.1 N. And whatever you do to one side, you got to do the other. But here's that same situation. I have a 1 T on the left, and I'm subtracting 0.1 T on both sides. So I have a 0.9 T left on the left side. 0.1 R, is, when I subtract on both sides, there's nothing on the left side, so negative 0.1 R and 0.1 N. Negative 0.1 N greater than or equal to, and the right side, there's nothing left, 0. Now there's a lot of points. You could write this out just like the words say right there. But if you want all the points, you've got to apply the algebra and get the variables to the left side so it's ready to enter in and be solved. Let's see. If your promotional budget limit is $18,200, how many commercial messages should be run on each television, radio, newspaper to maximize your total audience context? In this one sentence, we have two equations we got to write. One's a constraint and one's our objective function. Let's talk about the objective function. Max or min? Max. It's right there, the sentence says, maximize the total audience contact. We have 3 variables. We're maximizing, and we take each variable, T, and put what number will we put with T for this objective function? What number would be put with T for this objective function? You have how many? 100,000, is that what it is? 100,000. We're trying to have as many people reached, so 100,000 times T. Radio, 8 plus 18,000 times however many radio ads we're going to have, plus 40,000, however many we're going to do newspaper. There's what we're trying to max, according to that sentence. But then it says, stay on budget. How much? 18,200, less than equal, greater than equal? That's right. Our variables are how many radio, how many newspaper, how many television. Got to convert it to talk about money, because this is money that on the right side of this constraint. If I were to use the letter T, that's how many television. I have to multiply it times what? $2,000, the cost. 2,000 times T plus cost for radio. Is that 300? 300 times R plus the cost for newspaper. 600 times N. All of their individual costs for each variable less than or equal to 18,200. All right. See how we did. The objective function. The number of people reached, 100,000, 18,000, 40,000, times the individual variables, maximized. The budget, 18,200, right here. We use 2,000 times television, 300 radio, 600 newspaper. Did we do this 10? Oh, 10%. What is this one? Oh, there's more to it. It says there's only 10 TV ads available, period. T has to be less than or equal to 10. There's only 20 radio ads available, period. R has to be less than or equal to 20. There's only 10 newspaper ads available, max. So N has to be less than or equal to 10. Here is our part. 50% of the ads, what was it? It was radio cannot be more than 50% of all the ads placed. We got, after we did algebra, 0.5R, so a positive 0.5R on that next one. Negative 0.5T, minus 0.5N, less than or equal to 0. There's the 50%. And then, where's the next one? Television has to be at least 10% of all the ads. We did algebra on it. We got positive 0.9T, down on the end there in the bottom, minus or negative 0.1R, minus or negative 0.1N, greater than or equal to 0. And that's these two. This answer's been placed up already up on Blackboard. All right. Where is it? We're going back to the other media example that was on PowerPoint. You'll see that the constraints we came up with, there's at least one daytime ad, at least one nighttime ad. All those constraints I transferred to this. There were 16 constraints. Notice at the very top there, the first constraint, the company asked you to have at least one daytime ad. Excuse me. The right-hand side was a 1. The left-hand side were the 3 variables that represent daytime. So there's a 1 underneath daytime Friday, Saturday, Sunday. There's a 1 underneath each one of those letters. Now I posted this on Blackboard because your homework, you are going to need to put an Excel spreadsheet together and email the spreadsheet to me before your homework assignment is due. You can bring in your answers to the rest of the homework, your variables, your objective function, your constraint. But this part you got to email to me. You got to check your set box and make sure it's in your set box before it's due. As long as it's there, you don't have to worry about whether I got it or not. Hey, did you get it? As long as it's in your set box and we can both see that it's been sent before the time was due, that's good. That's fine. And this is a task. We could just open it from there. It'll be graded based on that. Now, what I suggest is I've posted 2 or 3 of these. You can open up any one of them and just rechange it instead of creating a whole new one. Whichever one might fit what you need the most. You may have to subtract constraint rows here if this one doesn't fit.
Do you not need things for like the inequality symbols?
You don't need it yet till we get down here. Because when we do this on Excel, when we're entering each constraint, it's going to ask us less than equal, greater than equal, or equal. We have to click on it. So to remind myself down here, let me see if I can get there. A little smaller. Right down here, I have what each constraint is, so that as I'm entering it, I can remember. Plus, with Excel, because those are 3 greater than equal in a row, I can enter all 3 of these at one time instead of entering each one individually. That's what I'm going to show you this time. Here's 1, 2, 3, 4, 5, 6, 7 in a row less than. I'll do all 7 of those together, and then I'll do these last 2 together. So it'll save a lot of time. I'll show you the shortcut. Go ahead, man. You're going to ask me? No, John? Someone's had their hand up. No, you just, all right. Now here's where all your optimal solutions are going to be. You just put zeros in there. But here, you have to put a formula. And that formula is always your objective function numbers, 3,000, 3,000, 3,000, 400, 400, 475, multiplied by that optimal solution, and then added together. And if you see the cell locations, E22 times E26, plus F22, F26, and so on, exactly how we wrote out the objective function. And then each one of these have formulas in them, which the only thing you'd have to do is notice this is going from E, this would be E6, those numbers across there, times the optimal solution for each variable, all added together. But let's say the problem you're doing only has 5 variables. How many do we have? 1, 2, 3, 4, 5. So you'd have to get rid of the last 2 parts of this formula to make it so that it's only for 5 variables instead of, this one's using like 7 variables. So you wouldn't even have to write this whole formula for each of these if you just look at it and say, okay, I got rid of column J, I got rid of column K, I need to get J and K now off of these formulas because I don't have that many variables. If you decide to use this spreadsheet, just tailor it instead of rewriting everything. So the formulas, the hardest part most people find is right there where the objective function is, and the left-hand side for each one of these constraints. You can either use this to help you determine what should be entered there, or we can just use this and just cut off parts at the end that you don't need. All right, I'm going to turn it blank for a minute so I can open up the thing and get the answers out of there because it always saves them. Again, I'm going to data, I'm going to solver, getting the answers out of there so you can't see them. Again. You gotta get those constraints out of there. You get it, and zip. I'm going to get it. Come on, delete. Delete. Here we go. All right, open it up. Everything's blank. Right here is asking for your set objective. This was on your quiz, I think, or one of these were. You look at your notes, and you look, and it says, oh, this is the cell location where blanky blank's at. What do I type in here? I hear it, louder. E28. It's the cell location where the objective function is being calculated. So I'm putting, now dollar signs or no dollar signs, I don't think it matters in this particular case. Now I want to make sure you realize what dollar sign means in Excel. It means if you're going to copy and paste something, and it has a dollar sign before it, you're telling Excel, don't change that letter, don't change that number when I copy and paste. You don't want to change. Let me make sure you got them. Uh-oh. Hang on, it's not what I meant to do. Do this homework. Let's keep going. There it is. Dollar sign E, dollar sign 28. I don't think you have to have the dollar sign, so I'm not going to mark it down if you don't. But there's going to be things coming up in the future where the dollar sign in front of either the letter or number of both is very important. So you've got to make sure you understand it. Is this a max or a min problem? This was advertised. Man, are we trying to max something or minimize something? Max, okay. What is this asking for? By changing variable cells. What is it asking for? Give me at least one of the cell locations. E26, F26. It's all of these cells. Let me scoot this over. Where the optimal solution. Excel is going to change these numbers so fast to find that optimal solution that it happens in seconds. But that's what it's asking for. Which numbers do we, Excel, get to change to find that optimal solution? Where are the cell locations? Right there. Wherever your optimal solution cell locations are. So I got dollar sign E, dollar sign 26, colon, dollar sign K, dollar sign 26, that whole row. Here we go, our first constraint. Looks like we've got we got like 16 of them. We start right here. Let's add a constraint. The left side of the first constraint is right there, but because there's 3 in a row that are all greater than equal, I'm going to drag the left side. I'm holding down my left click. I'm dragging all 3 of those. So instead of saying just E32, E32 colon E34. All of those cells at the same time is going to be our left side. They're all, this is why I can do this, because every one of them are greater than equal. And then the right side are the same 3 cells over here. Again, right there, drag it. Same number of cells. I got 32 for 34, 32 for 34. So it knows the right side and left side, all 3 of these at one time. Hit OK. There they are. I'm going to add. This time I'm doing right here, less than equal. Drag it. Well, these are all less than equal, all the way to there. So 41. 35 to 41. E35, E41. These are all. Hey, was that last one less than greater or greater than that last one? Did I put the wrong thing? I did? Okay, but this one's less than equal. I'm clicking right there. Now the right side, I gotta match it up, start at 35, right there, drag it all the way to 41 to match the left side. I can't tell if I'm there. That looks like it, right? Is that 41? Sure is. 35 to 41, it matches, they're all less than equal. Now, I can click OK, but I know there's more to do, so I'm even going to hit the word add here without going back. I want to add more constraints. Just clears it for me. I've done all of these to here, right? Is that 41? So all I have left are these bottom ones. I don't know how many are there. This one's greater than equal, this one's greater than equal, and that's it, just these 3. And then it goes to less than. So 42 through 44, greater than equal. On the right side, I'm going to go to 42 through 44, right there. All greater than equal, is that correct? There's just 3 of them. And then I'm going to hit add. And we got these last few. 45, E45 through E47. These are all less than equal. Right side. 45 through 47 there. Hit OK. There they are, grouped together. 32 through 34 are the greater than equal. 35 through 41 less than equal. 42 through 44 greater than equal. 45 through 47 less than equal. You can do each of them individually if you'd rather. I was just trying to show you a shortcut. All the other demos, I've put them one at a time, just to make sure you get it. Okay, am I ready to hit solve? Yes or no? No, what do I have to do next? That's right. Which one, right here, is you talking about this, right? Open this window up, he says use simplex LP, perfect. Am I ready now? Huh? Oh, you gotta check this box, that they're non-negative variables. That's right. Now we're ready. Solve. Hit okay. See how fast I went? We gotta go up here to the optimal solution. Do you remember how many people it told us that we'll reach with the optimal solution? Now, does anybody have the PowerPoint in front of them? Raise your hand so I can look at you. Is this optimal solution 7 daytime Friday ads the same as the PowerPoint? There's an alternative optimal solution. 5 daytime Saturday, is that the same? 3 daytime Sunday? That changed. 1 evening Friday? Wow. 0 evening Saturday? That's the same. 0 evening Sunday? It's how many there? 1. And the Sunday's 2 because it's you know, that's 2 on both of them. But notice our objective function value is exactly 199,000, just like the optimal solution was on the PowerPoint. Just we found an alternative. But this number will never be larger, no matter how many alternative optimal solutions there are. This is, and if we were to graph this with this many variables, it's next to, you know, if we were, you would see that every one of the alternative optimal solutions are all on that line where the what is it called? The feasible regions touching, where if you could graph the objective function, it would be touching at the edge. The optimal solution is always on the edges. All right. Can you use Excel to solve your homework within the 2 days? We're going to get a lot of yeses. And if Excel is not your thing, you've been avoiding it, this is the time where you got to start to embrace it because you have so much Excel in front of you over the next year and a half and several other classes that this is about prepping you and getting you ready for it. You ready? Now, where am I going here? We're going to start one more, see how far we get before we run out of time. We're going to slide, I don't even have the slide number. Blending. Yeah, we're going to do, Wednesday we're going to talk about any finance majors. We're going to talk about how you use this to do portfolio selections for customers. Operations, supply chain majors. We're going to talk about scheduling productions using linear programming, but we're trying to, we may skip this one. I don't want to freak you out. This is scheduling employees to do work in the production process, which that was a pretty hard one. We did that one already, but we're going right here. We have not done this one, right? Product mix? I don't remember, have we? Does this look familiar? Okay, here we go. Another example. When I talk about this one, I imagine this is like one of you saying, you know what? I'm going to college. I'm going to start my job. My job's probably, you know, I'm probably going to put in some overtime. I'm going to be new with my career. I want to prove myself. I want to get the promotions. I want to get the big raises at first. So I don't have a lot of free time, but when I get home from work, I got a little time. And in your garage or in your basement, you came up with this idea that you thought, you know, I'm going to start this little business and see if it does anything. And this is the way you do it. You don't say, oh, I need $1 million to start this business to see if it works or not. No. You start it in your garage or your basement, and you spend as little money as possible. And you see if your idea truly does have what you think it has. Or is this imagination? So are you truly solving a problem? Now this one, this may not be solving a problem, but this person said, hey, I have a dog or a pet of some kind. I don't know if it's a dog or cat, but whatever food I'm feeding this made me think about I could do better. This is you thinking, by the way. I could do better. I could put together pet food just like this, and it would be a lot less expensive. You know, I'm getting ripped off here, but I love my pet. I want to give them something better. I'll make it myself. So you came up with this idea to use your pet food mostly has grain in it, and you've been having conversations with suppliers, with other pet manufacturers, with companies that represent pet manufacturing, food company, and you find out that these are the 4 grains that you would want to use. And in those grains are a certain amount of vitamin C and protein and iron per pound. And then your costs are over there. Now, in order to do this, you said, here's where I'm gonna spend my money. I wanna automate this. If you go to a printer, you find out what it costs to have half-pound, 8-ounce package printed with your logo and your name put together. You subcontract that out. You get those, and on the internet, you found these old, used grain dumpers, I call them, where you set them for a specific amount that it dumps into the bag as it's going by. Gets to the second one, you've got it set at a specific amount, it dumps that as it's going by. Third and the fourth grade. This is all about you figuring out what the combination of those 4 grains are going to be in order to make that pet food the least expensive you can make it, and so that you can offer it at a discounted price, which was kind of your main goal a little bit, is, hey, I can do this better for less money so that people don't get ripped off. And at the same time, you want to make sure and meet government regulations that you learned about as you're investigating this idea of having your own pet food. And the government said, you got to have a minimum of 6 units of vitamin C in that pet food. And you have to have a minimum of 5 units of protein in that pet food. And 5 units of iron. Now most students look at this and they go, look, all of this data given to me is per pound. But the story says I'm putting together a half-a-pound bag. And so your first instincts are, don't I have to convert all of these numbers in half? And if your variable said, okay, first of all, I kind of gave away what you're trying to decide. My question for you is, how many variables do you think you have if you have not looked forward under the PowerPoint? How many variables do you think you have if you haven't looked forward? Your decision is how much of each grain will be set on that machine to dump into the bag. And at the end it passes all the grains possible, the decisions you have to make, that it will have exactly a half-a-pound, which will be 8 ounces, or a half-a-pound at the end. Now all it needs is to be sealed and ready to go. So you only have 4 variables. When that bag goes by, what did you set that first dump machine to dump in there? Part of that half-a-pound. But what part? The second one, what part of a half-a-pound being dumped in from that one? And the third and the fourth. When you're done, the 4 numbers you come up with to set that to have go in is going to be a portion of the half-a-pound. And it's all what portions of those are going to be. But when you add them all up, they're going to be exactly half a pound, because when the bag gets to the end, it has a half-a-pound in it. So these are your variables. X1, X2, X3, and X4, which is how much of each grain will go into that 8 ounce, which is a half-a-pound bag. Now, as you can see, the objective function, as I said, is the whole thing that inspired you is you felt like you were paying too much for the food you were buying for your pet. And your inspiration was, I bet you I could do this for a lot less money and have just as good, if not better, pet food. And you found out this is the key to getting these 4 grains that would make yours superior over theirs, or at least equal to it, and making sure you meet government regulations. Because they'll come in and grab one of your pet food, or several of them off the shelf at any time from anywhere, and they will see to make sure you're meeting these requirements. Statistically, all they need is 30 bags, and they can make a conclusion about all the bags made at the same time those 30 were made. Statistically, that's all you need. It's a minimum of 30, where you can infer from what you found out from those 30, all of them that were made at that time. All right. It's time to go over the homework problem. We'll pick up from right here on Wednesday on this blending problem. This is where we're going here. But I got to prepare you for this homework. You only got 2 days to do it, and I don't want you to struggle. I want you to understand what's being asked for here. It's a lot easier unless you try to read too much into it. Akron Industries manufactures several lines of decorative and functional metal items. The most recent orders come in, and the orders for 1,440 door lock units, complete units. But there's 3 components to that 440 units. So you need all three of these components, 440 of each, to put together to fill this order. The three components, knob and plate is a component, lock is a component, and a set of 2 keys is a component of the set. The whole thing. But you're looking at this as 3 individual items that you're trying to make decisions on. Every one of those 3 items will use up some of the brass, raw material that you have, and you just found out there's only 14,500 units, pound, whatever, units of brass. And here's how much each one of the 3 components would use as it goes through that department during the manufacturing process. There's only so much time in the machining, and each of these need to be machined in one way or another. And here's how much time in units it will take for each one of these. The keys, the lock, the plate and knob. Finishing department only has 12,000 minutes available. Here's how many minutes each one of these 3 would take in that department. You see the restrictions? Do you see the constraints? They're kind of jumping out at you a little bit. And right now you think there may be only 3 variables, possibly. You know, how many knobs and plates and locks and key sets should we make? We're going to schedule this based on these limitations we have and the fact that we have to have at least 1,440 of each. Get that? That's the one everybody's getting mixed up right now. I'm going to say that sentence again. In the other class, most of the emails have been missing this. You ready? The restriction is, on this grid here, the number of units available, but in the story, it says you need to have at least, you need 1,000, I don't even want to say at least, you need 1,440 complete. All 3 components. All of them 1,440, so you can fill the customer's order. You with me? Now, we realize we don't want to give up this order, but because of our limitations, we cannot make 1,440 in the time constraint that this order has to be finished by. So in order not to lose the contract, you get a hold of another company that kind of does what you do. And you explain the situation, and they're willing to pick up the ones you don't have the resources to make, so you can still fill the order, but you have to pay them a lot more than what it would cost for you to make it yourself. So you obviously want to make as many as you can, but to fulfill the order, the last blankety-blank amount need to be filled by them, and you're buying it from them and then reselling those, all the ones you made plus the ones you bought, to your customer you're getting the contract with. Everybody hear that? And here are, if as many as you can make, here's what it costs you to make each one of these parts. $5 for every knob and plate, $6.25 for every lock, and a set of 2 keys, $1.15. Don't break this up, because every one of them needs both keys. So you need a set. And how much is being used of every resource is for both keys together. You don't need to break this up into 2 keys. That's a set. So it's just one variable, not 2 different variables. The keys, a set of keys is a variable. I'm not going to tell you how many variables you have, but it's not 3. Let me tell you that. Because you have more decisions than just how many to make of the lock, how many to make of the set of keys. You have more decisions than that. The story continues. I didn't put it there. Huh. Develop a linear programming model that would tell Akron Industries how to fill this order for 440 lock sets. That's all 3 components together. And what I should have put here, and I thought I had, a linear programming model will give me every variable and what define that variable. What does the variable represent? Whatever letters or whatever symbols you decide to use. The objective function and every constraint. That's the linear programming model. I need all of that. The variables, objective function, and all the constraints. That's part of your homework. That's the part you're handing in, or you can take a picture, however you want to get that to me like normal. But after you've written that all out, I left down here, I said, now solve this problem using Excel. Don't forget, when I get your Excel spreadsheet, I can see who created it, I can see the last date is modified. So if you have someone else's that's helping you, you still need to create your own. Just use that as information on what you're doing. Or if you use one of mine, at least I can see that it was created by me, but I'll be able to see the date and time you made changes to it and made it your own. So So just give me a hint there in case, you guys go give up on this and say, somebody just give me this. I don't want that to happen. I don't want you to give up. Call, text, hey, are you getting this? And talk to each other. Once you've done that, you go in and you solve it, and you're handing in the solved version. Save it after you solve it. And then you email it. And then you write down the answers to these questions. How many key sets should be bought from the subcontractor? When you look at that output, when I look at your spreadsheet, it's got to match your answer here. How many lock units will they make themselves? The lock part of it, not the whole thing, just the lock part. If Akron Industries is going to receive $33,000 for this contract in revenue, will this cover the total minimal cost for making and buying these components for the total amount they need? So you are going to, I think the objective function is probably going to give you the answer to this. Because it's probably, you're eventually going to look at it and go, I'm probably trying to minimize my total cost to make sure I maximize the profit from this contract that I can. And you know how much you're going to receive in revenue. Somewhere on your output is going to be the total amount you got to spend to make and buy these to fill this order. That's what I want to see in your explanation. Here's how much our revenue will be. Here's how much our total cost could be for all these parts. The profit's this much. Then tell me yes or no if you're going to go with the contract.
What was the subcontractor and the Larkin cost? Are those two different costs?
Yeah,
you're
Larkin,
dealing with?
if they make all three parts to put together themselves, they have a certain cost. Where is this? Up at the top?
Yeah. So that's just
So if
two
we do
different-
it ourselves, we're going to spend $5 to make it, $6.25 and $1.15 to make each of these, but we don't have enough resources to do them all. Whatever we're subcontracting out, we're going to pay $9.75, $9.40, and $2.35 for each one of these. So obviously, when you are putting together a plan, let's say you were doing this by hand, not doing it using linear programming, you want to make as many as you can and use up all the resources because this is the only way to maximize your profit. But there's no way to fill the order, so the least amount that you have to buy from the supplier, from the subcontractor, is going to be your goal to keep that extra cost as low as possible so you can still fill the order. In real life, sometimes you have to end up buying so many instead of making them that it eats up a good chunk of your profit and makes the contract not worth taking. And that's what you, in real life, that's absolutely a decision that's being made every day in businesses that do manufacturing or whatever the contract is. If they don't have the resources, a lot of companies will say, I don't want to lose this contract. I've seen a company say, I'm still taking the contract, even though it's obvious I'm going to lose a little bit of money, because I have such a good relationship with this customer on other orders, I don't want to hurt that relationship. The loss is minimal. I'm still going to do it. I've seen that in real life. As a matter of fact, one of the first companies I ever worked for purposely sold items to a handy-andy, a bunch of handy-andies, which you guys have never heard of. They're like Home Depots, but they're in Chicago and somewhere. Purposely sold it at a loss because all the other things they order, the company made so much money off of. To keep that relationship and to stay competitive, we sold the opening price item at a loss on purpose. Because if we don't sell it to them and keep this relationship, somebody else is going to sell it to them for a loss, and all the other items they buy from that competitor, they're going to make money off of, and we're going to lose that money. So it's worth it to us to sell that item at a loss. And what was making the company do that is they was a manufacturer in Mexico that was making it for so much less that they were able to sell it for handy-andy truckloads of it at less than what we could sell it for. We had to match that price. The company I was working with had to match that price on that one item. But we knew with all the other things they ordered to keep that relationship, we're going to come out ahead. So they went ahead and did it. Everybody feel like they can do this? I'm going to give you my hint. I'm going to post this in just a few hours. Maybe take a shot at it tonight while it's fresh in your mind, because if you wait 2 days and wait before class starts, you're going to lose some of the stuff I talked about a little bit. But I will have this posted tonight so you can check the thing. Wait, I'm sorry. Hang on. I didn't have an in-class assignment. I switched it to Wednesday. I got to take a pen real quick. It only take me a second. Hang on. Okay, thank you. All right, guys, I'll see you in 2 days.